Hi everybody. Okay, welcome to the first video for section number 3. In this section, we're going to concentrate and get started with doing the implementation of the CRUD operations. And of course, remember CRUD stands for create, read, update, and delete, basic operations within MongoDB. And we're going to be doing this particular section in PHP. But before we get started, we got to have a discussion. And what that discussion is going to be about is what we're going to create. In other words, the days where you just sat down at the keyboard and started banging out code are pretty much dead and gone. And any project today, especially a web-based project, requires at least some planning and thought as to what we're going to do, how we're going to do it, and how it will be deployed or designed. So our system that we're coding for this lesson is a user system. And by user system, I mean this is a system that users are going to use to log in to our web application, and we're going to maintain the user database. Now that implies several things, as you'll see as we get deeper and deeper into the course, but I'm trying to keep it at a fairly high level and fairly simple with respect to the code requirements, because I don't have, and neither do you, have hours and hours and hours to spend on this. So in our system that we're designing, in the last section, we concentrated on logging into all the various configurations that Mongo offers. In this section, we're going to start the actual coding for putting data into the database, pulling data out of the database, updating and deleting data. Before we get started though, and again, we're dealing with a user storage system, we need to know exactly what it is that we're going to be storing. Now, some of you that have worked with Mongo before would say, who cares? Mongo is schemaless. If I want to store this field, I'll just store it ad hoc during runtime. And that, of course, is a legitimate statement. But it's going to be better off in the long run if we do some database planning. And the next few slides will show you the reason why I say that. First of all, we have to answer some questions. And those questions that we need to answer are, what exactly is it that we're trying to store? When we store information about a user, what user data are we trying to capture? And this information that we're going to be storing is going to be largely dependent on the type of application that you're going to be running. For example, if you're writing a website for coupon redemption, you're not going to need that much user information. However, if you're writing a web application for a doctor's office and you want the user to put in as much information as possible, you're going to get considerably more data about the user. So again, you need to figure out what the application's purpose is, and based on that purpose, what user information are you going to require in order to allow an outsider to create an account on your system. So do we want to get the user's name? Do we want to get their email, which is a unique field, by the way? Do we want to get their phone, their street address, their work address, city, state, zip, blood type, their school information? There's tons and tons of data that we can collect. And we want to focus on the intent of our application and narrow that data down as succinctly as possible. Today, in the current environment, when you sign on to a website and you create an account, users have lost a lot of tolerance for filling out long, lengthy forms. And website adoption, or your user adoption rate, is going to be a lot higher, corresponding or directly proportional to the amount of information you require they submit before you allow them to create an account. And over the years, what I've seen is we've reached the stage of minimalism where you can actually go onto some websites and create an account with simply an email address and a password. And that, of course, is the absolute minimum 2 pieces of information that you would need for most accounts, using a traditional authentication challenge response type of a login. Enter in your email address, enter in your password, we validate one against the other and both of them, and you let the user in or you don't, depending on what they typed in. So we need to determine what we're going to collect from the user. And then we need to look at the data that we're collecting, and we need to figure out what's going to be our primary key for our collection. In other words, what is the key that guarantees that a record is unique? What's the key that guarantees quickest searching? What is the key that identifies a particular record? Also important is we want to know what the common search keys are, because when we are setting up the database, even in Mongo with schemaless design, we still have to create indexes. So to create an index, we have to know the data that we're collecting, but we also have to know what of that data, what is going to be searched on the most frequently, because you don't want to build a web application and you don't want to have a large number of users, say you've got 15 or 20 million users in your system, and have somebody do a full table scan because they're doing an esoteric search. In other words, your searching of your user database should always be against an indexed field. So once you know the data you're going to collect, you need to figure out what your primary key is going to be to prevent duplication of records. And second of all, you need to figure out what other fields within your data are going to be indexed so that you can return data as quickly as possible to the user, because users don't like to wait. And then finally, we have to ask the question, what is this data linked to and how am I going to use it? How does changing data in this collection or adding data to this collection impact data in other collections? So you have to kind of think ahead, go fast forward in your brain and say, okay, I'm creating a user collection here. What other tables, what other collections within my database would need to access the user data? And the most obvious answer is the session table. The session, of course, is when a user logs in through a website, they're given a session identifier, a session key. Usually this is a form of a GUID value. And that session key keeps track of that user while they're using their application. In other words, with every request that the user submits, the session key is part of that request, and the system validates that it is a valid active session before it processes and honors the request. So in our program, we're going to initially start off with creating two new tables, one for our users and one for the sessions. Or at least we're going to have two data entities, one for users and one for sessions. The next question that comes up is, how are we going to design these data entities? Okay, so in the user collection for our program, what I've decided is we're going to collect the following information. And to me, this is pretty minimalistic. We're going to collect the first and the last name, because I could have some username like Itchy Scratchy 345, and it doesn't tell any other user anything about me at all. But if I store my first and my last name in the database, then it's nice when I'm sending out emails to my users, or if I'm referring to other users while on the website, I refer to their actual real life name and not their username. And I would go that a step further. If I was writing a web application that we were going to generate a lot of emails from, or secondary contacts to our user base from, I would split out the first and the last name so that I could use personal forms of addressing an email. So I could send an email out that says, hey, Mike, did you know that our website has this, instead of, hey, Michael Shallop, or hey, Itchy Scratchy 304. You see, so the data you collect, actually, you have to think about the data you're collecting so that other features that you add to your software suite down the road, it's compatible with those features. Username is obvious. When the user logs into the system, you're going to ask for a username. Some people would say, all I need is an email address, and that's fine. But I have an email address, me personally, I have an email address that takes me about, thinking off the top of my head, 22, 23, 24, 27 characters to type. And I'd much rather log into a system typing an 8 or 9 or 10 character username than I would typing 30 characters that make up an email address that I happen to be using. And of course, we're going to need the password. The password is a string value. It's a hashed value. And in today's levels of security, hashing doesn't really do it, or different types of old methods of hashing aren't secure. We're going to go ahead and use a hash password anyway, because the only thing worse than a hash password for storage in terms of security is a clear text password. So I'll go ahead and show you how to hash the password, and we'll store that password value as a hash value and not as a clear text string. The next field we're going to store is the email address, and the email address is kind of interesting in that it's a unique value. No two people have the same email address in by design on the planet. So an email address is a perfect candidate for a primary key if you want to opt for using string-based primary keys or self-identifying primary keys. An email address is perfect. Another good choice for a primary key is a phone number, especially if your system, your application revolves around someone's phone. Speaking of which, phones is the next field that we're going to record, and you can see that the data type for phones is a type array. And the reason why this is a type array is I'm leveraging one of the features of Mongo, using a subarray within my collection or within my table. And back in the days of relational databases, if I created a user account, most users had two phone numbers. You know, if you go back to the 80s or the 90s, most systems only collected two phone numbers, right? They collected a work phone number and they collected a home phone number. And then you got fax numbers started entering the picture, you know, in the business office. And someone said, well, what if I want to record a third phone number? And the computer scientists all had to rush back to their code IDEs and code in the support, maybe add a new column to the table in the database. And then somebody said, oh, well, look, cellular phones came out and I want to add a cellular phone or a beeper number, or I want to add my house hardline, my home phone as my home phone. I want to use my cell phone and I want to use a work phone, a fax number, and I have a home fax number as well. Well, it starts to get complicated because in a traditional SQL type relational database system, every time you added a new phone number or a requirement to store another piece of data, that would imply that you had to add a new column to the database. And in a relational database, we wouldn't even store the phone numbers with the users. What we would do is we would create a second table and we would allow users to put whatever phones they wanted in there, but we would link back to the primary field in the user table. And that involves a table join or two queries to get that information. Mongo lets us store subarrays, and we'll create the phone numbers as a subarray field within our user data, and then we can put as many phone numbers in that as we want. So we're denormalizing a traditional relational relationship of two tables, one-to-many relationship, by just adding that second table as an array to the first table. The other fields, date joined, it's like a created date. It tells us when our user joined into the system. A status field is used to indicate what is that user status. Are they in process of creating the account? Is it a new account? Have they validated through email yet? Are they still pending validation? Are they an active user? Have they been suspended for misconduct? Has their account been deleted? They have a lot of different statuses we can apply to this, and the status field will tell us what shape that user's account's in, because a user may have an account on our system, but we may want to suspend it or revoke it or put it in a state that doesn't give them full access to the system until they complete some requirements. So status field's pretty important. And then finally, I have a token field listed, and that token field is going to be a 36-character GUID. Now, for me personally, I've gotten away from integer primary keys. They're just too revealing of data. If I log into a system and they're using an API type backend where I can see on the URL bar of the browser, I can say, you know, the site domain.com/ ampersand user ID equals 1276. Well, they've obviously, you know, assigned my user ID as a post variable to the page. And my first thought is, gosh, I wonder who user number 1 is or user number 0 is. And the point being is that integers reveal too much information about the internal schema of your system. So I opt for a token primary key for all of my database collections simply because it's pretty much guaranteed to be a unique value and you can't derive anything from it. It is just simply a GUID. It doesn't reveal any information about your users. It doesn't reveal any information about your schema. So in our database, we're going to have a 36-character GUID assigned as the token, and that's going to become our primary key. Now, in the notation for the indexes, I've got this notation for compound a couple of times. And what I'm saying here is that the status field plus the username is going to be one compound index, where the status field will be the leftmost index within the compounded index, followed by the username. We'll have a second index using status and date joined, and the date joined will be the rightmost field in that particular two-field compound index. Our email will be flagged as a unique type in the database. And remember, in Mongo indexing, unique is a special indexing type. And what that does is that guarantees that our email addresses that are put into the system are indeed unique. In other words, Mongo will not let us store a record if an email address for the new record is already in use within another record. And the nice thing about that is we don't have to write any code for it. Mongo will take care of that checking for us automatically. And then finally, again, the token is the primary key for our collection. So we're looking at a user collection here that has a total of 4 keys, 4 indexes. And that means, as a database designer, as a database architect, you have to keep in mind that means that every time I do a destructive access to this collection, or in other words, every time I create a new record, every time I update an existing record, or every time I delete an existing record, I'm basically going to be performing that action n times, where n equals the number of indexes that I have assigned to that collection. So in other words, I'm actually on my hard disk drive, I'm going to have, since all of the data is stored in all of the indexes, I'm going to have 4 copies of my user table. And this is something that as a designer, you want to be well aware of, because if you're planning for a system that's going to use 50 million users and you're collecting, let's say, 50 fields of information about each user, well, 50 fields times the length of each of those fields times the number of users times the number of indexes ends up consuming quite a bit of disk space. So again, while you're planning your tables like we're doing now, you want to plan very thoughtfully in terms of not only the number of fields you're collecting, but the number of indexes that you're using, because that impacts the overall size of the database. Okay. So that pretty much sums it up for the users. Let's scamper on and go through the problem about session management. Now, this is a traditional problem in any system design. And you have basically 2 choices to make here. And the first choice is a traditional relational model where you actually have 2 collections. The square box is a collection. And it says basically users have sessions, and that implies a one-to-many relationship. Our second option is to create sessions as a subarray within the users collection. We only have one table, one collection to query whenever we want to get user or session information out of the user table. However, there's some problems here. There's some trade-offs. So in a traditional relational model where users have sessions, we have 2 collections, and the sessions table, as you can imagine, will probably grow to be much larger over time than the users, because users can have multiple sessions. So if I have 5 million users and each user logs in 5 times, I have 25 million sessions. The advantage of keeping the 2 relationships discrete in their own collection is that you can shard the session table, but the disadvantage is you're going to need multiple queries to get the data out of MongoDB. If you embed sessions as a subarray within the users table, you can get all the information about the user, including all of their sessions, their session history, with a single query. The downside is disk management, especially the longer your system is in use, the more data you're collecting. It's entirely possible, if you're not using a sharded collection, that you could run out of disk space in your database. So the questions you have to ask yourself is, how many users am I going to have? How many sessions per user can I count on? How popular is my app going to be? If I'm writing this application for my family and I'm only going to have 20 or 30 users, then by all means, I'm going to collapse everything down into a single collection. But if I'm writing an application that's going to have 5 or 20 or 100 million users on it, I'm going to have to seriously think about how I'm going to establish these relationships within the database. And I'm going to have to look at storage costs. because if I've got 50 million users on my system and each user is expected to log in 30 or 40 times, you're talking about 200 million sessions that I have to keep track of, which pretty much just screams a sharded collection, which means I've got multiple replication sets out in the cloud, and none of those replication sets, the last time I checked, are free. So your storage costs, big, big, big consideration. Data retention policy is another thing you need to consider. If I'm writing an app for myself and my friends, if I want to delete sessions, I delete it. But if I'm writing a healthcare application, my data retention policies are mandated by federal, state, and local laws. So you have to know what your data retention policies are for all the data you're collecting, because this does have a significant impact on your data design. So our session collection, if I was going to design it off the top of my head, is going to pretty much look like this. I'm going to have a user GUID, and the user GUID is the first field. It's an index field, and it provides a link back from the session table to the user table. I want to know when the session started. I want to know when the session ended. And then I'm going to have a subarray called user data. And I usually create a user data subarray, and that's pretty wild, wild west for me in terms of what actually goes in there, because that's dependent on the data that you get in the web request from the post. In other words, what do I want to know about the browser type? Do I want to know what their IP address is? Do I want to know what the last website they visited was? Anything that comes through in a post request or in an HTTP request, I can just unilaterally store that in the user data subarray. I'm going to index that field because there's going to be times when I want to know who's accessing my system from a particular IP address. So if I'm storing a user's IP address and I'm burying it in the user data subarray, I want to index the user data column so that all columns within the user data container are also indexed. And if I have to search for a problem user, this would make that search run very, very quickly. And then, like the previous table, I'm going to have a status field and I'm going to have a token field, because all sessions should have a status. The session at the very minimum is either active or it's not active. So if a user logs out of the system, when a user logs out of the system, or if the session has expired, you want to update the session record. And of course, we'll do that in the lesson covering the update of CRUD. So to recap, I have to make a decision now for our application. Do I want two collections? And the user collection has 4 indexes and the session collection has 4 indexes. That gives me a total of 8 indexes that I'm maintaining for this relatively simple relationship. Or do I want to combine, flatten out my, denormalize, flatten out my 2 tables into a single table, maintain the user sessions as a sub-collection under the user record, and in which case I get 8 indexes if it's flat. In other words, if it's flat, it means all of the fields of the session are now flat at the top level of the fields in the user table. Or do I want to bring the sessions over as a subarray? And that means I would move from 4 indexes up to 5 indexes of my data. For simplicity's sake, for the purpose of this course, what I've decided to do is go with the users and the sessions as 2 discrete collections within our database. And we'll have to manage those individually, and we'll write the code to do that. But it'll just be easier in the long run than trying to mess with a lot of subarray queries. It'd be a little bit beyond the scope of what we're trying to accomplish here with just understanding basic CRUD commands. So that's how we're going to set up our database for users and sessions.